In video 16, CAD and CNC. In video 15, we took a brief look at computer-assisted design, or CAD, which is usually the beginning of the manufacturing process. In this last video, we're going to look at CAD as it relates to CNC, or Computer Numerical Control. This combination of CAD and CNC are the foundational tools of manufacturing worldwide. They have been around for many years and share something called a Cartesian coordinate. To understand what that is, we'll go back to rulers and tape measures and look at something called a carpenter's square. Let's label one ruler X and the other ruler Y and mark the 0, 0 point right in the corner. We'll measure out 12.9 in the X direction and 8.4 in the Y. That gives us a point. We can graph that same point on a calculator. The Cartesian coordinates of that point are 12.9, 8.4. Now let's move that point in the negative X direction, so it's now at 0, 8.4. Now we'll move it in the negative Y direction, so it's now at 0, 0. Now let's move a point in 3 dimensions, from the inside of a work envelope of a Cartesian robot to its home position, at the upper rear right corner. And let's look at what that actually looks like on a Cartesian robot. This is the machine homing. It starts by moving in the positive Z direction to Z0, then moves in the positive Y direction to Y0, and last it moves in the positive X direction to X0. That's called machine home. Now let's take a look at the work envelope. For the machine to get back into its envelope, it has to move in a negative direction in all 3 axes. And the work envelope size is limited by the extent of travel of each axis. This machine is perfect for drilling the kind of pilot holes we looked at in video 12. And just like the point on the calculator that we were moving around, there's a point inside the spindle that gets moved by this CNC Cartesian robot. CNC machines are repeatable, accurate, and fast. You wouldn't want to do more than a couple of these boxes with hand tools. This CNC robot is cutting an opening for one of those power receptacles that you find on the back of computers. In video 15, we saw how CAD software was used to plan, design, and build an enclosure using structural aluminum. But if you wanted to create a part from a solid piece of aluminum, you would use CAD software to first design the part you wanted, and then CAM software, or computer-assisted manufacturing, to generate the tool paths used by the CNC machine. The CNC machine moves the tool based on instructions called G-code. A simulation of the tool and the tool path can be seen here. And here's the actual tool cutting the actual metal, following the same path. Community colleges are a great place to start if you're at all interested in CAD, CAM, or CNC. I recommend visiting them to find out what kind of CNC machines they have and if they have any additive manufacturing like 3D printing or water jet machines like this. Some community colleges and trade schools have older CNC machines, like these Bridgeport Easy Tracks. They are still great learning tools, even though the specific programming or G-codes may have changed. You can even opt to build your own CNC machine. There's a whole community of machine builders in this Village Press publication or on YouTube. Whether these videos have helped you to use a hand tool or helped you find a well-paying middle-class career, I hope you have found them all helpful.